Hey guys, so we're going to do lesson 2 for our organic chemistry unit now, which is alkenes, which is talking about a double bond. So carbons with at least one double bond are called unsaturated, and again the reason why they're considered unsaturated is because there's an extra spot where a hydrogen is missing from, essentially. So we have our double bond, right? So in Science 20, we talked about the trigonal planar shape of this. And basically, the reason why it's unsaturated is you could theoretically break this bond and put a hydrogen here and a hydrogen here to fully saturate it. So that's why it's considered unsaturated. So the shape that I'm using my kit, they're a little different than the ones you guys used with the springs, but the double bond would look something like this, and you can see that the shape that it has in it, so kind of looking like that. Okay, so for alkenes we have the suffix "ene", so everything is going to end with "ene" instead of "ane". Now the general formula for an alkane, again, CnH2n plus 2, because those two hydrogens on the outside. So when you form a double bond, you've actually taken away two of the hydrogens, so one from here to form this double bond. So the formula is only CnH2n. Okay, so and again, the reason why is because you're losing a hydrogen from each of the carbons. Okay, so the first member of the alkene is ethene. And the reason why is because, well, methane can't exist because the double bond has to be from carbon to carbon. So if there's only one carbon, you can't double bond with yourself. So the first member is actually this one, which is ethene. So C2H4. So 1, 2, 3, 4 hydrogens. Okay. So what's the first, because of the double bond, we now have a new isomer. So the reason why we have new isomers is we can now start to move this double bond around, obviously not with ethene or propene, but once you start to get into butene, we can have but1ene or but2ene. So we'll talk about naming and why we can move those around. Let me just make sure you guys can see all of this. Cool. Okay. So we need to number the position of the double bond with the lowest number. So we're always looking for the lowest number when we're dealing with naming our organic compounds. Always find the longest chain, and it has to have the double bond. So the double bond cannot be in a branch. So just make sure that when you're looking through things, you might have to go like up and down and make sure that the double bond has to be included. So even though that means that the chain might be shorter, you have to include that double bond. So let's look at an example of that. So let's look at our very first isomer. So we have... Okay, let's fill in our hydrogens. Now, it doesn't really matter if you do the structure like this or if you put it up and down. It's not a big deal for that. So we have 1, 2, 3 bonds already. So we only actually have one hydrogen that can go there. And then again, it doesn't matter if you do the condensed or the structural diagram. They're all the same thing in terms of the location of the double bond. That's totally fine. So this would be called but1ene. Okay, so but 1, 2, 3, 4 carbons. The 1 represents the lowest number of the carbon that it touches. So we have 1, 2, 3, and 4. So this is where the 1 comes from. And then we have ene because it's an alkene. Okay, so that's why we label it as such. So it is an isomer of this structure. Let's just fill in our hydrogens this way because I'm lazy. 1, 2, 3, so one more, and then 3. So this would be called but, and then 2ene. So we have 1, 2, the second carbon. So let me just show you that there. Okay, and you can't actually make but3ene because but3ene really is just but2ene but flipped around, right? Just like this is a hand, you just flipped it. So it actually is still just but2ene because that's the lowest number possible that we want in there. Now let's look at some little more complicated ones. So let's go to CH3. Okay, and then a C double bonded to a C, CH3, and then CH3. So now we'll fill in my hydrogens. I only have one that can go there, And none can actually go here because we already have all of our bonds. 1, 2, 3, 4. So there's no more room for a bond there. So let's start with our naming. So we have to have the longest chain. Okay, now I have to decide what side I'm going to start numbering at. So either over here or over here. Now if I go here, 1, 2 is where my double bond's going to be. If I go over here, it's still 1, 2. So the reason why I'm going to start on this side is because the next step is to see the lowest number for my branches. So in order for this to be the lowest number for my branch, I'm going to start over here. 1, 2, 3, and 4. So this is going to be called 2, a 1 carbon, so methyl. Okay, so 2-methyl bute 2-ene. And remember, the ene stands for that alkene, that double bond there. And of course, many examples to go from there that we can do. Just remember your steps. So the little joke, my little awesome chemistry jokes, I know you've been missing them so much. Help me, I'm diene. So when you have 2 double bonds, it's called a diene. Di meaning 2, ene meaning double bond. So these are going to be isomers of alkynes. We haven't done alkynes yet, but alkynes are a triple bond. So basically, when you look at the formula for a diene and an alkyne, they're actually going to be the same. Okay, so let's look at an example of a diene. So we're going to start here. So we have starting with our carbon chains, and I'm going to put a double bond here, and then I'm going to add my hydrogens. So I have 1, 2, there's only room for 1 here, and 2 here. Okay, actually I should keep the same kind of structure. Okay. Awesome. So doesn't matter what side I start from because it's a mirror image. So I'm just going to start here. 1, 2, 3, and 4. So this would be called bute 1, okay, and 3 diene. Okay, so a 4-carbon chain on the first and the third carbon. There's a double bond. Okay, so that would be bute 1, 3 diene. And again, if you are following along with the filled-in versions, there are many other examples. So again, I'll just probably do 1 or 2, and then you can follow along from there. So please make sure you're still looking at the on the website, the filled-in version, because there will be more examples from there. Okay. Yeah, so let's move on to our alkynes. All right. I don't know why I made the same joke twice. Oh, I took it off. Okay. All right. So, do you know any organic chemistry jokes? I know alkynes. Alkynes. Yeah. Alkynes that you wish I probably didn't do, but yay, I love them. All right. So let's look at our alkynes. They're all kinds of fun. Yeah, it's actually, the laughs are just as loud as they are when I have you guys in here. Crickets, none. Okay, so the general formula for alkane, CnH2n plus 2, alkenes are CnH2n, and then alkynes are CnH2n minus 2, because every time we make an extra bond, we take away 2 hydrogens. So that's why we have a minus 2 there. Sorry, I know it's kind of hard to see with the light. It's just on that part. So, all right, you'll just have to follow along with that. Okay, so let's do some examples. So let's look over here. Okay, fill in our hydrogen. So we actually have room for 1 over here. So we have our hydrogen. We don't have any room there. We have room for 2 here and 3 here. So this would be called 1, 2, 3, 4. So bute 1 ine. Okay, so on the 4-carbon chain, first carbon, there is a triple bond. That's where it goes from there. So again, many examples that you can go through in that. Same thing with the, if there's two of them, it just becomes a diene. So same rules as before. And again, please go through the examples in the filled-in version that I provided for you guys with that. So yeah, just some examples there. So let's look at one more that's a little more complex, and it has to do with priority of naming for rules. So let's take an example. 7. Okay, 1, 2, 3, 4, 5, 6, 7. All right, so we're going to put a triple bond here, a double bond there, a triple bond here, and we're going to put a branch. So let's just look at this example. Now, in your filled-in version, I did not include the hydrogens, so I will just fill those in for you guys if you're following along. So I'm going to do it condensed. So we would have 3 here, none here, none here, 1, 2, 3. So only 1 here, 1, 2, 3, 4, none there, 3 there, 1, 2, 3, 4, none there, and just 1 there because we already have 3 bonds. Okay. Now, so we have a double bond, we have 2 triple bonds, and we also have a branch. So let's think of how we're going to number this, okay? Now, we know that the longest chain is going to be here, okay? And we have to include all the double bonds and triple bonds. Now, if I start labeling over here, not only does it make a big number for my triple bond, but it also makes a really big number for my branch. The reason why I'd start here, the first reason is because the triple bond's located right there. So I'm going to start numbering over here. 1, 2, 3, 4, 5, 6, and 7. So let's just write that down. I have a hept. So hept is the prefix for 7. Now let's look at our double and triple bonds. Now, alphabetically, ene comes before ein. So when I name it, I'm going to put the ene first. So I have a 3 for my double bond. So hept 3 ene means that on a 7-carbon chain, on the 3rd carbon, I have a double bond. And then I also have 1 and 5, I have a triple bond. Okay? And then the last thing is my branch. So on the 3rd carbon, I have a methyl group. So the name of this shape or formula or structure or molecule, however you want to word it, would be 3-methyl hept 3 ene 1,5-diene. So there's your structure for that one. Okay? Yeah, awesome. So I believe that is the last one, except for, of course, my jokes. It says before organic chemistry, and then after it says I'm diene. So love it. I know you guys aren't. This is second nature to you guys by now. So that's your one joke for that. Oops. Organic chemistry is difficult. Those who study it have all kinds of trouble. And then, according to a chemist, why is the world so diverse? Because it's made of all kinds of people. And then, chemistry can cause all kinds of trouble. And then acid, what you did there. So we're going to learn about carboxylic acids later with our naming. So all the jokes in the world, they're so awesome. Now this is just a little joke for if you ever do go into organic chemistry in university. You talk about the configuration of your 6-carbon cyclos, and basically you learn about what's called the boat or the chair shape. And basically, when you get into organic chemistry in university, the location and configuration of where your hydrogens are and your groups and stuff like that is important. So you'll hear a lot about boats and chairs. If you also take biochemistry, they talk a lot about this because the shape of most sugars are this 6-carbon ring. So there's a lot of them in there. Yeah. So another chemistry joke. Putan for the single bond, ene for the double bond, and that should be a Y for the triple bond. Yeah. But there you go. Some more chemistry jokes for you. And unfortunately, we're done with the jokes. All right, see you guys for our next lesson.